Hi, I'm Dr. Mamari and I'm going to perform experiment 1 of Chemistry 1032 lab at Central Campus. The purpose for my experiment today is that I provide you with the data for experiment 1 so you could complete your data sheet or the homework assignments and submit to your professor as an assignment. I'm going to concentrate more on the procedure part. As I said, due to distance or remote learning, students cannot be in the lab to perform the experiment. I perform the experiment and I take a video of what I'm doing. I will show you how I collect this data, and you are going to record your numbers based on the experiment as you're watching the video. Your professor, if it's going to be me or any other professor teaching the lab, can hold mini session of the Blackboard, collaborate and explain about other aspects of this experiment, the theory. For example, for experiment 1, I'm going to share the document. It's going to talk about safety. So while you are in the lab, you have to follow the safety rules, and it can be explained again. You can read. The experiment is actually available to you in detail in a folder called experiment 1 document. So the first document is the document that contains the experiment, that contains the introduction theory part of the experiment, how to read a measuring device, if it's a ruler or graduate cylinders. For measuring length, you would use ruler or meter stick, and for measuring volume, you are going to use graduate cylinder. You could use burette, you could use pipette. The measurements in the lab involve significant figures. So when you are measuring a quantity of anything using a measuring device, you are going to report the number based on accuracy of your measuring device, which is going to have all the digits, certain digits, with exceptions to one digit that is uncertain or estimated digit. When you report the number with that property, it's said to be that your reported number is significant, or you are reporting number with proper significant figures. And anytime you are reporting a number, you would have like 3 parts to it. One, certain digits. One would be uncertain digit, which would be the last digit in the measurement, and that would be the uncertain digit. Like here would be 5, would be uncertain digit. In this case would be again 5, and here 2 is the uncertain digit. Then your number is reported with the significant figures. So certain digits, everything else like 5, 0, 8 here is certain digit, 2 would be uncertain digit, and then the last part is kilogram, which is the unit. Counting of significant figures, it will be explained to you by your professor in either lab or the lecture. So I don't want to make this video too long, so I would leave that part to your professor. So, and you can also read the document to understand how to count the significant figures. And when you are adding numbers or subtracting number, how would you apply the significant rules? Basically by counting the number of decimal places for adding, and your reported number, your answer cannot have more decimal place than any given number. Or when you're multiplying, the number cannot have more significant figures than any of the given numbers. So if you have 2 and 4 significant, your final answer should be rounded up to significant figures. When you are measuring volume using a graduate cylinder, the points that you want to keep in mind, your eye should be at the same level of the liquid in a cylinder shaped equipment. That could be graduate cylinder or burette or pipette. The liquid in a cylinder shaped equipment stays in curve shape, and then when you are measuring, you have to read the number across from the lowest point of the curve, which is known as the meniscus for the level of the liquids, or the lowest point of the curve, which is called the meniscus. So we are looking for meniscus, and you are going to read the number across from. If there are lines there with the representing numbers, and if the meniscus falls between the lines, then you have to estimate the last digit. So the numbers, if it's exactly on the line, the last digit would be 0. But if it's between the lines, then depends on how close is the higher upper number or a lower number, then you have to estimate your numbers. When you are using a graduate cylinder that is a 10 milliliter graduate cylinder, you have to report the number with 2 decimal places. With 100 ml graduate cylinder, you are going to report with 1 decimal place, because you could see the numbers. The numbers represents the ones place. So then you would use the 10th place using the estimated number if it falls between the two lines. For beakers, these are equipments that they are designed to transfer liquid from one to another, from larger container to smaller, or when you have mixing a reaction mixture and you don't use it, they are not the best for or most accurate devices for measuring. Thermometers is going to measure the temperature, of course. Meter stick would measure the length. Balances would measure the mass, and based on the accuracy of the balance, you would see 1, 2, 3, or 4 decimal places, and you have to record all those numbers. Whatever you see, you would record on the scale. Bunsen burner, or use of the Bunsen burner, you have to make sure that you have a proper ratio of gas with air combining in the Bunsen burner. So the supply from the gas comes from the wall. So you have a gas hose that is connected to the gas valve that is in the wall, and you have a gas adjustment valve underneath the burner. Depends on the design of the burner that you're using. Underneath or on the side, you would have a valve to adjust it. The air valve adjustment, in this case, like by rotating this movable cylinder here, you can lower the amount of the air combining. If you don't get enough air to mix with the gas that is burning, you would get incomplete combustion. And how does it show? It will show yellow color flame, and the flame is not going to be hot flame. At the same time, it's going to produce carbon monoxide, and that is not good for the lab, because you're going to inhale carbon monoxide, you're going to have smoke in the lab, and also the temperature is not going to be the highest. When you adjust properly, you would 2 or 3 blue cones with different shade of the blue, and the top of the inner cone is going to be the hottest part of the flame. If the gas is on today, I'm going to turn on Bunsen burner for you to see it. Measuring density is, you're not actually measuring density, you're going to calculate density. In order to calculate density, you are going to measure mass of the object and the volume, divide mass by the volume to get the density. Units for density are gram per milliliter for liquid, gram per cubic centimeter for solid, or gram per liter for gas, because density for gas is very small, so we have to take larger quantity or larger volume of the gas in order to measure the mass, to be able to have reasonable numbers to work with. After the introduction part, you have pre-lab questions, which you are going to complete these, and they are presented in this course as the pre-lab quiz, or under the quizzes, you will see the pre-lab for experiment 1. You would complete that. Then you have the procedure, which is the major part of my work here. I'm going to follow this procedure, and I will get the data to you, or ask you to record the data as you're watching. And then when you are done with the data, you are going to complete so these numbers from 1 to basically 1 to 13, you are going to record these numbers. Everything else is calculation, which you do it at home. So we're just going to do complete 1 to 13 here for you to record the numbers in order to be able to turn in your data sheet. I'm going to stop sharing the document, and I'm going to follow the procedure from printout for the procedure to perform the experiment for you. Okay, first part of the experiment. Measure the volume of water in 10 milliliter graduate cylinder. Those are actually set up for us, and the setup is right here. I have a 10 milliliter graduate cylinder. I'm going to bring it close to the camera so you could see what I'm talking about. This number is now, you see the numbers, number 5 and then 6. This number is between 5 and, the level of the liquid is between 5 and 6. And if you look closely, 1, 2, 3. Okay, so it's 3 small line over 5. So we have 3 between 3 and 4. So between 5 and 6, there are 10 units, 10 smaller units, and each one is going to be 0.1. So if it's 3 higher, between 3 and 4, line about 5, then you are going to get the number between 5.3 and 5.4. And that part is going to be exact number. So it's not estimated. So nobody is going to estimate this at 5.2 because it's actually over the 5.3 and is less than 5.4. So now your estimated number is going to fall under the 100th place. So the second decimal place is going to be estimated digits. So between 5.3 and 5.4. So if you can see that for the meniscus, maybe you can see it better. It kind of gets blurry when I bring it closer, so I'm going to read it and would give you the number at this point. It's actually, to me, is exactly at 5.3. Because it's exactly at 5.3, I'm going to record it as 5.0. So for 1, it's going to be 5.30 milliliter, and then 2 is the measuring the volume in the 100 ml graduate cylinder. The 100 ml graduate cylinder, also to you. That number is now between 80 and 90, so we have to count how many lines over 80 or below 90. So what angle I can keep for you to see it better. So I have the 80, 85, 86, 87, 88. The meniscus or the lowest point is between 88 and 89. It's closer to 88, but it's not exactly at 88. So I'm going to estimate it as the 88.3. 88.3, because the last digit is estimation anyway. So 88.3 milliliter. That's the second one. 3 is the 3, 4, and 5. These are the volumes in the burette. Basically, when you are reading a burette, it's not that you are reading how much liquid is in the burette. What you do, the first burette is just reading the number on the burette, it's the level of the liquid in the burette. So if we read here 43.1, it's the number is increasing from the top to bottom. You have 0 all the way to the top here, 0, and then you have 50 all the way to the bottom. So 43, 43.1.2.3.4. Okay, so if the number from the top, increasing from the top, if I read this number, is 43.4 and is exactly on the line. So I'm going to give a second decimal place because it's asking me to record with 2 decimal places, and it is 43.40. 43.40. So 3 is 43.40 milliliter. 4 is another burette, and the number is 23.56, between 6 and 7. So it's like half a way between 0.6 and 0.7. So I'm going to record it as 23.65. 23.65. 65. When I say milliliter, is actually wrong to say milliliter, because that's not what we have, but it's showing that is across from that line, that number. So we could say it at the mark of 23.65 milliliter, but we cannot say there are 23 milliliter of the solution in there, because when it starts from 0, unless you subtract that number from 50 and say that much liquid. But that's not the purpose of using burette. The purpose of burette is reading the level. So if we start from 10 and then we open this stopcock and we deliver or transfer 10 milliliter out, it's going to come to 20. So the difference between 20 and 10 is the volume of the liquid being transferred out. So basically it's a measuring device that it's a graduated measuring device, and it gives you an option of how much flexible number, how much you can take it out, and it's very accurate. Burettes and pipettes are the most accurate equipments in the lab for measuring devices. For the third one, it's 1.55 from the top. So we have that's station 5, 1.55. I'm going to write milliliter because your data sheet asks for milliliter, or it says milliliter, so I'm going to write that. So next one for 6 is beaker. Beaker is not a measuring device. It's more of a transfer of, if you want to transfer anything less than 50 milliliter, you can use beaker, this 50 milliliter beaker. If you want to transfer something for a volume of around 400 milliliter, or any volume between like 100 or 50 milliliter and 400, you could use this one. The numbers are graduated numbers going up on the right side, going down the left side. So you can actually say approximately how much you're taking out, or how much liquid is in the beaker. So for the data sheet purposes, for station 6, between the level of the liquid is between 20 and 30. It's closer to 30, so I can say this is like about 28, but 8 is the estimated number. Someone could argue with me even via that video, via a camera, and say, no, I think it's like 29, or you might say it's 27, but that is the point of last digit being estimated digit. And since I'm reading it now, I'm just going to say that I think is 28, but I cannot say it's 28.0 because I'm not sure about the 8. How could I say the 0.0? Because then means that 8 is certain digit and 0 is like a certain over the certain. That doesn't work. It doesn't work that way. We have to stop with the uncertain digit. So we cannot add more decimal places. So 6. For 6, we have 28 milliliter. This is the milliliter because we are counting actually how much we have. So this one, we have between 20 and 2050. There is another line between 20 and 2050. So it's the 200 and 25, between 200 and 225. So I have to estimate number like that is between 200 and 25 is more than 200, less than 225. So 200 and I could say if it's exactly half, then I would say like around 210, 212. So that would be like an estimated digit anyway. So next 7. For measurement 7, it's going to be 210 milliliter. More than 200, less than 250, and the best estimate of mine, it was 210. For 8, we are going to try to turn on the Bunsen burner. I'm not sure if the gas is on or not, but I can definitely try. As I told you, when the design of the Bunsen burner is different based on the design of this Bunsen burner, the air valve adjustment is like if I'm rotating this cylinder to the right side, I'm closing the gap, so less air is coming. To rotate it to the left side, I allow more air to come in, and the amount of the air is it should be proportional to the gas that we are using, we're allowing to combine. And how do we know that? Is from the color of the flame. If I put too much air, this is going to start like making pop pop sound, and with that pop pop sound that is making, that means that be careful is turning off, and it did turn off. If I put too little air, it's going to give me yellow color flame, and that's not what I want. So I'm going to open it, start with the yellow color flame, open it until it gets blue cone, 2 or 3 distinct blue cones. So I don't know how many you see there, but there are 2 cones with different shade of the blue. The tip of the inner cone is basically the hottest part of the flame. So if I bring a copper wire to the tip of the flame, the gas line has not been used for a long time. That's why we have such a weak flame here. So you see the top of the inner cone, it changes the copper to red. It gives like a red color. It's about to melt it. But down here is cool flame. Up here is the hottest part of the flame. That the temperature here, based on the combinations of the gas, the natural gas with oxygen is about 1500 degrees Celsius actually is a very high temperature. So what is asking me to do here? Set up Bunsen burner and try to. And when you're setting up Bunsen burner, you want to make sure that it's not too far up, because if it's too far up, it would take much longer time to boil. And I find small heat here. I'm going to use it for boiling point of the water for the next step. Okay, holding piece of wire flame, locate the hottest part. So the hottest part of the flame was the top of the inner cone. That's the hottest part. Please write it down for part 8. And then the coolest part would be close to the base. So all the way down to the base is the coolest part of the flame. The top of inner cone is the toughest part of the hottest part of the flame. Now for part B, or the data number 9, we need the water to boil. So I'm going to go back to that for you because it's not boiling yet. So as soon as it starts boiling, I get back to that. For 10, using a ruler. So we are using ruler. There are like 5 pieces of paper here. I took the piece number 1, and in order to measure the length, I'm using the centimeter because this ruler has centimeter, and it has the choice that we are given choice of the centimeter or inches. I aligned the one side, the left side of the paper with the 0 exactly, and see if it falls under to what number. So the number that is from the end of the paper here, from one end to the other end, is 11, and since it's exactly at 11, see, since it's exactly at 11, I'm going to record it as 11.0. 11.0. So that is for length of piece of paper, and the paper, it was number and number 1 is paper number 1 is 11. 11.00 because it was exactly at 11 and centimeter. 2 decimal places, that would be 11.00. Okay, the water is boiling now, and since it's boiling, I'm going to use a thermometer, measure the temperature, and report it for part 9, or data number 9. Okay, don't know how. Okay, I'm not sure how, but it actually records 101 using this thermometer. So it could be due to atmospheric pressure, or the water is not pure water. but I cannot change the number, so I'm going to record what I got there, and it was 101 degrees Celsius. Degrees Celsius. Okay, for 11, we're going to measure the mass of object. The mass of the object that we are using is, the object that I'm using is object number 14. So you need to know the object number, and we are going to place on the scale. If it's not connected, I can bring it here. So I have everything in one side of me. Okay. The scale, you turn it on, you plug it in, it's on, on, then you press the tare button. When you press the tare, it's going to calibrate, and because there's nothing on it, it should show all 0. Then we place the object, and it shows the number with 3 decimal place, and that's what the procedure is asking us to record with 3 decimal place. And the number is 13.185, and that is for 11. The unit is gram. That was metal object number 14 for the mass. Measuring the volume. To measure the volume, we are measuring volume by displacement. What does it mean? Measuring volume by displacement is we are going to place a specific amount. It's not the exact number, but whatever it is, it has to be recorded exactly. Is a 10 milliliter graduate cylinder, you don't have much of a choice. It's going to be with 1 decimal place. So I put 25.5, so I'm going to 12, 25.5 milliliter. That's for 12. When I place the object inside the water, it's going to displace the water. The level of the water would go up. Then I have a final reading for the volume of water. The difference in the volume from initial reading to final reading, it's the volume for object that I'm placing. Often for objects that they are irregular shape, you have to use by displacement. You cannot measure the dimensions and then get the volume by formula. You have to basically use by displacement. If the liquid doesn't react, doesn't dissolve the sample, then you can use this this method. And it has to be more, the solid must be more dense than the water, the liquid also. Otherwise, it will float rather than sinking. So it went to 30.0. So 13 is 30.0 milliliter. we have the volume now. You can read in milliliter, but because it's solid, can then translate that to cubic centimeter. 1 milliliter equals 1 cubic centimeter. The volume for solid object is expressed in cubic centimeter or cc, and for liquid is expressed in milliliter. But numerical value is the same. For every milliliter, you get 1 cubic centimeter. Okay, you have all the numbers for your calculation. So I'm going to, at this point, I'm going to stop the recording. This is the end of experiment 1. It's not a very long experiment, but read the introduction part, ask questions from your professor if you have any questions regarding the theory part of this experiment. Thank you.